Okay, g'day students, and welcome to our first lesson on Earth geometry and time zones. We're looking at latitude and longitude today. So the goal of the lesson is to be able to 1, define the meaning of great circles, 2, define the meaning of angles of latitude and longitude in relation to the equator and the prime meridian. Now 3, locate positions on Earth's surface given latitude and longitude, for example using a globe atlas and other digital technologies. State latitude and longitude on Earth's surface using world maps, so we just want to do that in degrees, but use a local area map to find the position of a given place in degrees and minutes. So a great circle is a circle drawn on a sphere, so it's the circumference of a sphere that has the same centre as the sphere. So it's the largest circle that can be drawn on a sphere, whereas a small circle is a circle or a circumference drawn on a sphere with a different centre to the sphere. So the only line of latitude or parallel of latitude, we could really call them, which is a great circle, is the equator. And so we can see here that the latitude is flat. So remember, lat is flat, and we'll talk about that in a sec, whereas the meridians of longitude are all great circles, and longitude run up and down, whereas equator and other parallels of latitude, they're all parallel with each other, so only one of them is a great circle. Now latitude is the distance north or south of the equator, and longitude is the distance east or west of Greenwich in England, which is the prime meridian. So as we said, here's a visual of the previous definition. So you can see that the equator has a radius that is reaching into the centre of the Earth. So the equator, first of all, is a great circle. All the other latitudes are small circles. So they run flat across the surface of the Earth. So they're just going to be smaller circles. And so their radius is going to be smaller than that of the equator. If we want to read latitude and longitude, just remember we read north-south, which is lat, and then we read east-west, which is long, so it's lat-long. So remember, latitude is flat, so lat is flat, and longitudes are the longest. So if I want to have a read of a few of these coordinates, let's look at position A first of all. I need to read how far north of the equator it is. So here's my equator, and my equator runs along this line here, and I'm going up 10, 20, 30. So A is 30 degrees north of the equator, and then I need to consider how far east or west it is. So here's my 0 line, and here's my 0 latitude as well. So I'm going to turn left. So if I'm heading left, I'm heading west in this case. So I'm 30 degrees north, and it's 60 degrees west. So I'm reading latitude first of all, then the longitude. Let's have a look at another random one. Let's have a look at B, seeing it's nice and south. So I'm reading lat, then long, so it's below the equator, so 10, 20, 30, 40, so it's 40 degrees south. And then I'm reading, okay, it's just 20 degrees west. Okay, let's have a look at C now. So C over here. So it is below the equator, so it is south, and it's along this line. So it's 0, 10, 20, 30, so it's 30 degrees. So C is 30 degrees south. And then this time we're heading right from the prime meridian, and it looks like it's 50 degrees east in this case. You might want to sit there and solve the other ones. Okay, so we can just note the position on the Earth. That first of all, the Greenwich meridian is this line that runs along half of the Earth, so that's our Greenwich meridian there. On the other side of the Earth is the international dateline. Now it has just changed in a couple of years ago to just include a couple more of these smaller islands as well. So that's this one here. So between the Greenwich meridian and the international dateline, we have a line which runs 360 degrees around the surface of the Earth. Now anything that runs east. So let's see if I can do this. East is what, all of this half of the Earth, and therefore west is this bit over here. So that's west of the prime meridian. So you can see that I've scribbled over the screen, but the Earth has also got an east and a west hemisphere, so to speak, as well as a north and a south hemisphere. So let's try and locate a few different places using our latitude, longitude. So first of all, what are the coordinates of Singapore? So here's Singapore. It's right on the equator. So we could just say 0 degrees. You could say 1 degree north or 2 degrees north because it's just above it. But first of all, I think that we're happy enough just saying 0 degrees. Now that's halfway, and halfway between 90 degrees and 120 degrees is 105. So let's say, well, it's probably just a little bit less than that. So let's have it a roundabout guess at 100 degrees east. Now let's have a look at Bundaberg. So Bundaberg's about here. So let's look at this. We've got halfway between 0 and 30. Well, that's got to be 15. And you can see it's much closer to the 30 than the 15. So let's put it at about 25 degrees south. And then you can see that it's just a little bit further over after the 150 degrees. So it's on the 180 degree side of 150 degrees, but it's not that much more. So maybe we can say 155 degrees east. Now let's have a look at this one. What city lies approximately 30 degrees south? So here's my 30 degrees south. It's got to run along this line here somewhere. And then 30 degrees east. So I'm looking up here. Okay, so I'm running down this line and it's hitting that one. So it looks like Johannesburg in South Africa is approximately 30 degrees south, 30 degrees east. Now you might also come across some local area maps, and you can see that the scale is very different. So in between 144 degrees, now this has got to be east. This is in Australia, it's in Western Queensland, and it's from the Clermont local area map from Geoscience Australia. And now you can also go to QTopo and download maps as well. And we've got 60 markings between 144 degrees and 145 degrees. Now, 1/60th of a degree is actually known as a minute. And funnily enough, 1/60th of a minute is a second. So not to get confused, but we do have degrees, minutes and seconds on local area maps. But you can see that, well, there's a whole lot of nothing here, but we're going to try and have to consider the scale when reading the local area maps. So if I'm going there, well, I would say that's 144 degrees and 30 minutes. Likewise here, I'm going from 20 down to 21 degrees south. So that would be 20 degrees, and halfway there is 30 minutes south. So let's have a look at finding a couple of locations. So let's find the location of Hughenden. So what we need to do is locate Hughenden on the map and then consider our latitude line. So we just draw a line and make sure that's all nice and straight, and straight through Hughenden and then either side of the axis. And then we'll also put one for the longitudinal line, and then we just need to read it. So we just need to say, oh, it's 20 degrees and 21 minutes south. No, it looks like a whole lot more than that. So if that's 30, 35, 40, 45, 50, so that's closer to 50 degrees south, sorry there. And what do we got? 144. Oh, well, that's 5, that's 10. Well, that's got to be 12 minutes there. So 144 degrees and 12 minutes east. Now, what geographical feature lies at 20 degrees and 8 minutes south? So that's that line there. And then 144 degrees and 50 minutes east. And so that's that line there. And so we just draw our line there. Where they intersect, well, that's going to be Lake Cargoon, wherever that is. Okay, we've done a bit today. We've defined great circles. We've defined the meaning of angles and latitude and longitude in relation to the equator and the prime meridian. We've located positions on the surface of the Earth, particularly with a world map and a local area map. When you're good with that, please have a go at the mastery questions from 4.1.